Hi, today I want to talk about the object and classes. I know that some of you guys are coming in from different background. Some of you may already know some of this stuff. Some of you may not, or some of you may be taking classes at the same time. So I want to go over some basic stuff, and then we can talk about more detail and see how far we can go with this. In general, when we're talking about classes, we're talking about templates. We're talking about some conceptual ideas that does not actually exist in real world. So if I say Joe or man or woman or a girl or a boy or a car or a classroom or a house, you have some idea what those things are, but you cannot identify them. So a name is conceptually connected with a physical person. So when I say Joe, you're thinking about a male probably, and some idea how this Joe is going to look like. But till I don't show you the actual Joe who is in our classroom today, then you wouldn't know what I'm talking about, the physical. So when we're talking about the classes, it's just a concept, and we need to have a physical existence of a class before we can use it. So I'm going to go over some of this concept. uh, if you have questions, let me know. Put it in the DQ. We can talk about it. And for those who already had these things, then we can kind of create more challenging way of doing it. So I'm going to go quickly over this, and we are talking about object-oriented programming. So traditional programming was what? We would have a large task, we would break it down to the smaller tasks, and then we would focus on a small task. We would get the small tasks done individually or as a group, put them in together, and create a program. So, a while back, there come with this idea that if we can break the program into some smaller pieces, that we can take these pieces and move it into different program, and it would work. So it was like at the beginning when the computer manufacturing were creating computers, they were making every single part of the computer. Nowadays, if you look at computer organization or manufacturing or whatever you want to call it, let's say Dell. Dell doesn't make almost any of the parts that they are selling. So they get hard drive from somewhere, the memory from somewhere, different pieces. They put it together and they make a computer. And they might not even put it together themselves, and somebody else might put it. So that idea came along that if we can create the module that contains everything that it needs, then we can move it anywhere and it's going to work. And for that, when we were creating functions, the functions didn't have everything that we wanted. So they were having some task and they had some variable related to those tasks, but they didn't have anything. So they came up with this idea of the object and classes, that they would have the data and the methods, and now we can plug them into different programs that's going to work. So that's the concept that we're talking about. So when we're talking about a class, class does not exist. So we're going to create a blueprint of what we want to do. So if I want to build a house, I'm going to go, an engineer going to build draw a blueprint for me, but the blueprint is not the actual house. So it is an idea of the how the house going to look like. And that's what the classes are, an idea of what the class is going to look like, and then we're going to go create an object, the existence of this class. So when we're talking about the class, we're going to have a section for the data. Uh, Excuse me. I don't know what's wrong with my voice today. Uh, so let me bring this one over here. So we're talking about the data section and the method section. So the data is what we're going to need for this object when it goes to the existence, and the methods are the way that we're going to deal with this data. So we're going to talk more about this coming up. So we can have methods that we created in the class. And when we create an object of that class, we're going to have all the methods coming to us. So those are available to us. We don't have to recreate them. It's available. So for example, talking about the string object. So if I create an object of a string from a class of a string, I'm going to have all the methods comes with it. So in this case, we have a method called upper, and using a point saying that this method belongs to this object. So when we create multiple objects of the same class, we have to know which object that method is going to happen. So if I have a class called car, and one of the methods in that car can be paint. So if I go to a body shop and I'm going to say paint, excuse me, paint car, I have to identify which car is the one that they're going to be painting. So that the dot operator is going to say which object, which car do they need to apply the paint to it. And for that, then each class is going to have its own methods. And with the newest IDE, when you have an object and you push the dot next to it, it's going to give you the list of the methods available to it. If you're using some kind of a idle or similar to that, then those things might not be available to you to see what's available. But when you practice enough, you would know these things, and your generation has Google uh, that you can find things, so your memorization is not as much as we have to memorize all these things. And and as you work with it, you're gonna learn more about it, and then you're gonna use it. So when we're talking about a public interface, is how our object or the template of it, the class, is going to be talking to outside world. So if I have a house and I want to repair a faucet or I want to paint my bedroom, I have to give some kind of access to somebody to come to my house. And the public interface is how do they come to our house? How do they come to our class? How do we give them a permission to do anything with the data that we have? If I have my car and I go to somewhere to park it, I might give the key to the valet to park my car. So I'm going to give them an access to my car. He or she may not have access to my trunk, but he has access to drive my car. So those are the things that we're going to be designing in the classes, and how we're going to design it and protect our data. So the idea over here is when we are talking about the information hiding, when we are talking about public interface, these are the methods that are able to access our data. Either they're going to get the data or they're going to change the data. So the idea of not giving the detail of our methods to the person who wants to use it. It's called polymorphism or information hiding. And we're going to see that. And if you go and apply for any kind of a company who are using object oriented, they're going to be asking you that one, and we're going to talk about another one. So it's three things that you're going to remember for the object oriented. We're going to talk two of them this time and one next time. So if I have a transmission, if I do have a transmission in my car that I'm driving, do I know the detail of this transmission? I don't have no idea. And I have seen people opening the transmission and having all these pieces, thousands of pieces in the transmission that I would not even dream of putting them together. But I don't know those things. All I know about the transmission of my car is there is a stick in my car, and if I put it on a D, it's going to go forward, and if I put it in R, it's going to go backward, and if I put it in the park, it's going to stay in the place. So that would be the interface, public interface of the transmission to the driver. So they can use the transmission without knowing the actual uh, detail of the transmission. Same thing goes for uh, engine and the brake system. So I know if I push the brake pedal, the car is going to stop. That is the interface with the brake system. I don't have no clue how does the brake system works or how does the engine works. All I know is I can start it and I can turn it off. But how does it work? I don't know the detail of it. So the idea over here is when we are creating our classes, when we're creating the methods, the person, the next person who's going to be using these things, they don't know what the details. We don't give them the details. Encapsulation is information hiding. So that is what we're talking about here. So when we have the detail of a method, we are not going to show it to the person who's going to be using it. That's called encapsulation. So I mentioned polymorphism. We're going to talk about it in next chapter. We're going to talk more about it. But the encapsulation is the information hiding over here. So we are not going to give them the detail of the code that we are writing. We're just going to tell them what is this about so they can use it. So here, we're going to be talking about a simple class, and then we're going to expand on it into the more detailed one. So the book wants to talk about tally. So when the book is talking about the tally is something that somebody would hold to see how many people are going in and out of a place. So there is an event, somebody is standing on the door, by the door, and as people go in, they push it and they count. So for example, in this case, we have 123 people already passed through. So that's the tally. So it's going to have some data and it's going to have some methods. So the question is, what are the tasks that this tally is going to do? Well, it definitely is going to be incrementing it. And if somebody come and say, hey, how many people passed through this door? They're going to tell me 123. So that's getting the total. So these are the methods, some of the methods of this tally class. So do you know what the data of this tally going to be? The actual number is my data. I'm going to talk more detail about the rest of the stuff. So in this case, we're going to have a class called counter, and then we're going to create an instance of the counter. That would be my object, and then I'm going to call it tally. So the counter is my class, and I create an instance of it. Remember, I cannot use the class by itself, so I have to create an object of it, and that's through the constructor, which we're going to be talking about in a few minutes. So we have some uh, methods in this object. Remember, it came from the class, and we're going to be using a dot operator to call them. So one of them can be reset, and then we're going to do click click. So we reset it, my number becomes 0. Click click, that's going to give me 2. So my get value method is going to return the number that I have. And if I do another click, that get value is going to give me 3. And if I do a reset and I do get value, is going to give me 0. So this is the way we're going to be invoking our methods with the object that we created for by the class. We're going to talk more about how we're going to create our classes, and we're going to use some tools like Draw.io or Visio for Microsoft to be able to draw our UML. UML, a unified modeling language. So we're going to have that. We're going to talk about it a little bit in another video. We'll talk about that. We're going to use that. But you can use these things to create our classes. Right now, we're just going to do some simple classes, and then we're going to bring it up. So the idea is if I have a class, I can have multiple objects of the same class. So sometimes you see the example of there is some places that they work internationally, and they have a bunch of clocks on the wall that each one of them is going to represent one of their office location. So one office in Japan, one office in Hawaii, one office in China, and they have the time. So the class is clock, but each clock is going to have a different time of different places. So their instance variable is going to be different. So every object of the same class can have different value. So every car that you see in front of a body shop can potentially have a different license plate number, can have a different color, so can have different VIN number, so different year, make, model. So those are the instance variable of a class car, which is going to reflect to the object of a car that we are talking about. So we would have a class. Of course, we're going to put the name on the top, and then we're going to have a data, which is instance variable, and then we're going to have our methods that's called the public access, how we're going to access to this data. So in general, when we are doing object-oriented design, we want to hide our data from outside. So we have a key for our car, we have a key for front door. So if anybody want to come and access our car or our house, we're going to tell them how you're going to do that. So if somebody is asking for my car registration, I am going to go to my glove box, pull it out, and give it to the other. So the way that I access the private information that I have is I'm going to access it. So I can create another way of doing that, giving a key to somebody and tell them that the registration is in the glove box, go get it. So we can create those methods of how to access data. But in general, we want to protect our data. Now, let me get back to this. So we're going to have our class name. We can use that UML for designing our classes. We have our instance variable, and we have our public interface. So for a tally, we have the number that we have for the actual tally, which is private, and then we're going to have the methods that can access this. Now, coming to Python, being a scripting language, it cannot enforce some of the things that we can enforce in C++ and Java. One of the things that it cannot enforce is this private data. So in C++ and in Java, we define our data as private, and nobody from outside of our object can access those directly. In Python, we cannot enforce that. We just ask people nicely, please do not access this private data. And we're going to talk more detail about it. So if we want to create methods, the methods in Python, they need this variable called self. Again, Python cannot keep track of where it is. So by passing the self, we are passing the address of the current object. So that's the way it knows where it is. Otherwise, it doesn't know where it is. So we have to have this word self, which is pointing to itself. That's the way we can access the stuff. Otherwise, it wouldn't know. So we need to pass it as a parameter, and we're going to be using it with the dot operator. So if I want to access my instance variable, that's the way I'm going to be doing it. So in this method, I'm not actually getting any variable except the self, and I'm just going to add one to my current value. So we have different methods. Those are some the methods that are to get the information. There are some methods that they are going to set the information. So if I have a value as my instance variable, I can just get the variable. This is the accessor or getter value. So it's going to get the value, but it's not changing anything. So we can look at over here. We have this class that we are creating. This is the class we're creating. I'm going to talk about the comments and everything soon. And in this class, we have our get or accessor. We have our setter that is changing the value. And we're going to have this one that's resetting is actually resetting my value. So these are my mutators that they are changing the value and the accessors. Now, if I create this class as a file, I need to be testing it by another file. And we're going to talk about that in a short period of time. Well, let's talk about it right now. So this is my class. And for me to use this class, I have to create an object for it. So I'm going to create another program, and then I'm going to create the object of this class. Now I can use the methods that I have in here, and I can print it. So when we are designing the class, we're going to start with public interface. That means what is the responsibility of this class? What do we want to do? So we have two types of design. One is top-down design, one is bottom-up design. The bottom-up design is you take your requirement, you break it down to the smaller pieces, and you build your classes based on those. The top down is you defining or you identifying your objects and you build from there. And if we're doing that, that's what we're doing right now. The question that we're going to ask is okay, if I have this class, what is the responsibility of this class? What task this class is going to perform? And based on that, we're going to ask what does it need to be able to do those tasks? And that's the way we're going to figure out our parameters, and eventually we're going to figure out our instance variables. So the responsibility of this class called cache register. So we have a cache register class. So okay, what is it supposed to do? What task supposed to do? What is the responsibility for it? So the responsibilities, remember, we're going to do this top down, so we may miss some stuff that we can catch it later. So we're going to add the price, we're going to get the total, we're going to get the count, how many items do we have, and we're going to clear the cache register. So those are the tasks that we have. So if we have those tasks, we're going to create methods based on those things. So when we creating a class at this time, we are going to have only one class per file. But eventually, we can have modules that they can have multiple classes in it. So what I want to talk about here is about the comments. So I want you to pay attention to this, and I want to be sure that you do this way. So we have three types of comments. We have in the file or module level, we have the class level, and we have the method level. So in here, for now, one file is going to have one class. So we are not going to do the first one for now, and we're going to catch up with it later. So we have the class level that's going to explain what is this class going to be doing. And then we're going to have our method level. In this case, we have two of them. So what we're going to be saying is, what is this method supposed to do? And in this case, what are the parameters for this? In this case, what is it returning? What is going into it? What is coming out of it? And eventually, we're going to create a document out of this. So the ones that has £2 sharp sign, we're going to create a document. So the person who wants to use the methods that I have or the class that I have, that this is all they see. So for that reason, I have to be very careful about how I am going to advertise my methods, because it's not about I am writing this method right now and my program is working, who cares? It's about we're going to be writing our code in a way that's going to be used in the future, not only for other people, for myself. Believe me, you come back to your program in 6 months, you don't have no idea what you have done. So the comments are very, very important. And the Docker string, we talked about it earlier, is also very, very important to do. So when we create an object, basically what happens is it goes to the memory and it's going to create this object based on the template that we have, and it's going to return the pointer to that object that we're going to be assigning it to a variable. Now that I have the object, I can call the dot operator to call our methods of that object. Remember, the method is coming from the class. In this method, it needs a parameter, so we're passing the parameter. So again, we have two types of methods, accessors and mutator. Accessors are the one that we can call them getter and setters. So we can name them like that. We can say get or set. Uh, so instance variables are the one that's going to keep track of our data for our object. And of course, they are most likely different in different objects. So if I have five different objects, they may or may not have some of them equal, some of them are not equal, some of them have to be unique. So for my car, maybe a year, make, and model may be the same as some other cars, or maybe the color is going to be the same, but the license plate definitely going to be different. The VIN definitely going to be different. Then registration is going to be different. So we would have different. So if I have a car and I register it, then the name of the owner is going to be changed. So there is going to be an instance variable, the name of the owner, that's going to be changed. So how do we come up with the instance variable? Remember, we start with the task and responsibility of the class. So we're going to start, this is okay, we're going to have this task. For this task, we're going to have this method to do that. And the question is, what do I need for this method? So if I want to add item, I'm going to need the total and the count to be able to add item. If I want to get the total, I need the total. If I need to get the count, I need the count. If I clear it, I need to reset my total and amount and the count. So this is the way, again, this is the high level down, top down. So that's the way we're going to figure out our instance variables. So again, in object-oriented design and most of the object-oriented languages, we do not let outsider to access our data directly, but we cannot do that in Python. So we nicely going to ask people not to access the private data. And if you have seen some program out there, some people just go in there and do it, but that's against object-oriented design. So the way that Python identify those is putting an underscore in front of the variable, and that underscore means this is a private and is asking people, please do not directly change these variables. So we are applying encapsulation. That means we are hiding the data, the implementation of the data, implementation of our method from the public. So the method is going to be a way to access the data. So we are uh, hiding our data. Encapsulation is basically hiding the information, and we're going to give them a way to access it. Sometimes we're going to have some method that is going to be internal method, or we call them helper methods, that they don't need to be publicly available. So we're going to put the underscore on them too. So in Python, anything that starts with underscore means is private. Now, how do we create our constructor? What is a constructor? We used this before. Constructor is when we are building an object, we are going to be put some uh, data in it. So today, the plant is going to create for focus, yellow, two-door. So that's what's happening today. So when they're making those cars, they're all going to have the same color. They're all going to have two doors. They're all going to have the same year and model. So that's the default value for today. Because in Python, we don't have the variable declaration, we have to put some value for the variable to figure out its data type. We are going to do that inside our constructor. Some people do it in different methods somewhere else, but we want to do all of them in our constructor. So everything that we have in our instance variable, we're going to initialize it in our constructors. So a default constructor doesn't have no parameters, so we initialize everything to its initial value. If it's a number, we're going to set it to 0. If it's a string, we're going to set it to null, and so on and so forth. Now, sometimes we have some parameters that can go into my constructor. While I am building my object, I can pass some parameter to it. So I have a bank account, and I can have a parameter for initial balance that every time I create this bank account, I can put some money in it at the same time. So in here, we have amount that we're going to set it to our amount. So it's coming in as a parameter, and then we're going to put it as underscore amount. So by just looking at this, I have 3 instance variable. I have item count, total price, and the amount. Item count and total price have default value. Amount is receiving it through the constructor. So the way that we are declaring our constructors are the one with the 2 underscore. I have some space here, but it doesn't use the space. The reason that we have these spaces over here is for you to notice that there is 2 underscore next to each other. But in reality, when you're typing it, there is no space between these 2 underscore. Underscore init, underscore underscore. So Python is using the overloading function and default values a little different than the other ones. So we can use that in our advantage. So first of all, to be sure that we can have our default values and have our uh, initial value, we can do something like this. So we are passing these 2 parameters. We set this to 0, we set this to null, and then we put a colon, and we're going to say balance equal initial balance. So if the initial balance is not set anything, if we call it with no parameter, my initial balance becomes 0, and the name becomes this. If I call it with a number, then my initial balance becomes that number. Now, we have something in Python that we can, even though it's a default value, we can call the second. So in Java, in C++, when you have default values, you cannot go to the second one. You have to use the first one first. But in Python, you can skip over the first one and use the second one. So I can say the second one, I can put it as a value for it. So the first one is going to be default value. The second one, I'm putting something in it. So if I just put a number, it's going to use the first one. If I put a number and a name, it's going to use the first one and the second one. If I want to use the default value for the first one and just use the second one, this is the way I'm going to do. So it's going to use the name to my name, and then the balance is going to be 0. So Python doesn't know where it is because it's a scripting language. It's not compiled. It doesn't know everything. When it gets to that point, it has to pass the reference of its current object. So we don't have a choice. We have to pass that self. And then that's the way we're going to reference our instance variables. So when we creating and construct, when we creating an object, the address of that object is going to be saved in our variable, and that's the one that's going to be passed as a self. That's the object reference that's going to be used. When we are using the constructor, constructor is going to be used only one time. Again, Python cannot enforce that, but that's an object-oriented design way of doing it. So you will call your constructor only while you're building your object. You don't call that one again. If you need some setters, you're going to create your setter functions, methods to do those settings for you. If you need to call the init again, you're just going to create a new object. And remember, Python has the garbage collectors. So if you create another object, the reference of the first one is going to go away, and eventually it's going to clean up for you. So we don't have to worry about it. I know some of you coming from the C++ and you have to deallocate some of the variables and those kind of things. We don't have to worry about it. So this is the part that we're going to be working on this week. We're going to be working on how to implement our methods. So we start with the task. We talk about what method's going to carry on this task. We're going to say what variable do we need for this, and then we're going to implement our methods. So again, we don't want to access the instance variable uh, from outside, but when we are accessing it inside, we have to be using the word self. When we calling the method inside another method, we have to use the word self for it. So this is a sample from your book that is doing the cache register. We would put the init. We initialize our instance variables in there. We have an add item. We have a get total, and we have the get count. We have the clear. All those methods available. So again, this is not enforceable, but this is the design that we're going to be using, that all your instance variables are going to be created inside your init or constructor. The last thing that I want to talk about is, maybe I have one more thing that I want to talk about. We talk about a static variable in C++ and in Java. Here we call them the class variable. So when we are talking about instance variables, if you have multiple objects, they would have different values. So for example, if we have different cash registers, let's say you go to grocery store and 10 of them are there. Each one of them is going to have a different value, different total, different number of items, different things. But then they would have a shared value that's going to be shared with everybody. That's called class variable, or in generic, we call them a static variable. So if you think about townhouses, condominiums, apartments, so we have We live in an apartment building. Everybody has their own apartment. Inside your apartment, you have your bedroom, you have your stuff. But the laundry is a public location. So everybody's going to be using a laundry or a pool or a gym. So those are shared with everybody. So the good thing about it is they can, everybody doesn't need to have it inside of their unit. The one person can go and maintain it. But the bad thing is if something is modified, everybody's going to be affected. So if somebody goes and damage the laundry machines, everybody's going to be affected. If the pool pump doesn't work, everybody's going to be affected. So this is something that we don't want to use it all the time. We're only going to use it if we have to. So it's going to be done in the class level. That's called class variable or static variable. Again, if it is changed inside the class, it's going to be changed for all objects. Every class has access to this. Every class can change it. It's going to make it very difficult to know if we have a problem, we're going to go and figure out what's going on. So in this case, we are using the bank account number, the last number that was used. So when we're creating a new account, then we use the last number, we add one to. Or we can have constant variables that is going to be, for example, overdraft fee for $29.95 that everybody can use this. Again, Python cannot enforce constant variables. So when you see it all uppercase, we are asking you, please do not modify this value. Now, when we create a class, we have to test it. We're going to create these classes. We're going to put them together. We're going to create a project. So how do we test it? You can test it in Python shell, idle, or you can do the test driver. And that's what we're going to be doing in this class. So for every class that you create, you're going to create a driver class to test it. So what we're going to do is we're going to construct some object of this class. We're going to execute the methods. I am picky. I want to execute all my methods. I don't want to leave anything out. So I want to execute all my method. I would have some data to test it, and then I'll be sure that those tests are going to pass. Otherwise, I'm going to go and modify it again. So this is one of them. So we are using this import one. So from the cash register, we're going to be importing the cash register, and then we're going to test. So this is the way we're going to be using in this class. So we're going to come up with some data. In real life, we might get this data from the user. For us, we might use it, create it ourselves. What is it that we're going to expect, and then create. That's all I want to talk about for this session. And then we're going to have another session to talk about some other things.